Alright, let's take a look at this Algebra 2 problem. Log of x plus 12 base 10 minus log of x base 10 equals log of x plus 9 base 10. Let's solve for x. So for an Algebra 2, the first thing we would do is probably combine the logs on the left-hand side. So the logarithm of 10 of x plus 12 over x is equal to the logarithm base 10 of x plus 9. Okay, and so combining, so there's our equations. So then if the log of first is equal to the log of the second, then that means the first is equal to the second. Okay, multiply both sides by x, so x plus 12 is equal to x times x plus 9. Okay, so we have x plus 12 is equal to x squared plus 9x. And so we get 0 is equal to x squared plus 8x minus 12. And so from this point, we would use the quadratic formula to solve for x. So continuing on, we get that x is equal to negative 8 plus or minus the square root of 64 plus 48. All divided by 2. And then this simplifies, I'll skip the work, I get negative 4 plus or minus the square root of 28. So I have two answers, negative 4 plus the square root of 28 and negative 4 minus the square root of 28 by doing the algebra here. Now the problem is that one of these actually does work. So x equals negative 4 plus the square root of 28 works. But x equals minus 4 minus the square root of 28 does not work. And the reason that x minus 4 minus square root of 28 doesn't work is because that's negative. Negative 4 minus something, that's negative. And the log of, if I take the log of x, log of a negative number is not defined. So this first one works, but the second one does not work. Now what happened? I can combine logarithms, but this is a one-way implication, technically. I can split this up as long as the top and the bottom are both positive. But if this is a negative number divided by a negative number, then I can't split up the logarithm like that. So that's a one-way implication. Okay. Furthermore, this next step here is also another one-way implication. Okay. If the log of something equals the log of something, then the two somethings are equal. But if these two things are negative, then the reverse is incorrect. If that's negative 5 equals negative 5, I can't take the log of both sides to get log of negative 5 equals log negative 5. That's incorrect. Okay? All right, then here I'm multiplying by x, so that one, at this point, if x is, I'm not worried about x being equal to 0. Everything else here is going to be by implication. There's a technical point on this one that I'm not going to worry about because I've already got the logarithm to worry about. So, but basically, because I've got logarithms, these two steps here are one-way implications and not by implication. So we have shown that if there's an answer, it's one of these two numbers. So if there's an answer, it's one of these two numbers. But without checking, we can't know if either actually works, if either is a solution. Actually is a solution. And because I have at least one step here that's not a two-way implication, then there is the possibility that I might have an extraneous answer when I come out the other end.